Hey all, Mr. Boyden back at it again. Today we are looking at review for the trigonometry part of your semester 2 final exam. This is in class basically what the three classes told me that they're most concerned about or think might be the trickiest. So basically what the hope is here is that this video will kind of give you a little bit of a boost, a little bit of a jump start, so that you are ready to go study on your own in practice. Of course, the videos that we had from when we learned this back in units 4 and 5, and that's what I'm going to cover today is units 4 and 5, those videos from when it was first learned are going to be useful as well. What I'm going to try to do in this video is have some new examples, and I'm going to reiterate what the basic concepts are. So this is not totally comprehensive. There could be other things on your final exam other than what we talk about here, but I do want to make sure you have all of the basics down for this. Okay, so let's get started. The first thing we got to make sure you remember is SOHCAHTOA, and what that's saying is that in any right triangle, the sine of the angle is the same as the opposite over the hypotenuse, and the cosine is the same as the adjacent over the hypotenuse, and I forgot my theta, and that the tangent of the angle is the same as the opposite over the adjacent. Now, SOHCAHTOA itself only applies when you have a right triangle, same as Pythagorean theorem, only when you have a right triangle, because otherwise you don't have a hypotenuse, okay, so that wouldn't work. Now, this is probably a good time to mention that we need to remember our reciprocal identities. So sine, its reciprocal is cosecant. Okay, so I'm going to define that as 1 over sine. It is a reciprocal identity. We could have written it as hypotenuse over opposite. Cosine goes with secant. So secant theta equals 1 over cosine theta. And then tangent goes with cotangent. So cotangent is the same as 1 over tangent. Now, I want to remind you of something else as well. We also defined sine as a y value. Now, that's only true on the unit circle, and cosine was an x value. That's only true on the unit circle, which means that tangent is y over x, which is only true on the unit circle, which means that cosecant is 1 over y, which is only true on the unit circle, and 1 over x, which is only true where? Yep, you guessed it, unit circle, and then this one is x over y. Now, I've put those in red so you understand that that's something a little different. It's an extension of SOHCAHTOA, but again, only applies to the unit circle situation. What am I forgetting? I think I also want to remind you that if you want to find an angle, you will need to use an inverse. And what I mean by that is you type in like the second button or the control button in your calculator first. Okay, you'd want to make sure you did that if you're finding an angle. Now that was also true for laws of sines and laws of cosines because those are also extensions of SOHCAHTOA. SOHCAHTOA is kind of like our base understanding, and then everything else we learned is an extension of that. Okay, also the other thing you want to make sure to do is make sure you know whatever calculator you're using, you know how to switch it back and forth between degree and radian mode. That's something that would likely come up during an exam, and you want to make sure that you're speaking the right language to your calculator. All right, unit circle. We need to review the unit circle, make sure we know. That was one that when we first learned it, it was kind of intimidating, and then once we got it down, we go, oh, that's not so bad. So things we need to remember about the unit circle. We're typically going to use radians rather than degrees. This is 0, also 2 pi radians. Over here we have pi radians, and then I always build the circle off of that. So remember the circle goes this direction, right? Anti-clockwise or counterclockwise. Okay, so if that's pi, this up here is pi over 2, which makes this half of that, pi over 4. This is 3 pi over 4. 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 6 pi over 4 I skipped because that's 3 pi over 2. Okay, so we got all those ones. Those all have certain things in common. So all of those, in fact, the ones that are kind of out at like this northwest, they're out at 45-degree angles, they always have root 2 over 2 in the coordinates. So this one's root 2 over 2, comma root 2 over 2. This one is reflected. So negative root 2 over 2 and root 2 over 2. And down here, we have them both negative because we're quadrant 3. So negative root 2 over 2 and negative root 2 over 2. And here we're quadrant 4, so the x is positive. So root 2 over 2 and negative root 2 over 2. Okay, so we're all set with those. What about sort of those cardinal directions, the north, south, east, and west? So over here, the coordinates are pretty easy. 1, comma 0, and 0, 1, because we're going up, so the y value is 1. Negative 1, 0. Down here, we are at 0, negative 1. All right, so those are pretty easy to remember. There's only a couple others that you need to be aware of. We need to be aware of also what happens at all these other locations, but they all have something in common. They're all based on this angle being a 30-degree angle. So they're based on the 30, 60, 90 triangle, which you probably learned about in geometry. So I want to remind you, this first one is pi over 6. What we talked about when we learned this in class is we said the ones that are closest to the x-axis are going to be some numbers of pi over 6, and we remember that because 6 is spelled with an x and the x-axis has an x in it. That'd be a way of remembering that. So this one over here is 5 pi over 6, 6, 7 pi over 6, and then we have 11 pi over 6. Okay, and those all have coordinates in common. They're just reflected the same way these ones in red were. So here, what we remember is that we have the shorter side of the triangle is always 1/2, and the longer side of the triangle, when it's a 30, 60, 90 on the unit circle, is always root 3 over 2. So the x is longer, the y is shorter, so 1/2 for the y. That reflects over to here, so now we have negative root 3 over 2 and 1/2. Then we're going to come down here, and we have both negative. So negative root 3 over 2 and negative 1/2. And root 3 over 2 and negative 1/2, because we're down. Okay, so we got those. Now we only have one more little spot we got to fill in. We'll do this one in purple. Those ones are over 6. This is twice as much, so these ones are over 3. So this is pi over 3, 2 pi over 3. Let's see, 3 pi over 3 is here. So this down here is 4 pi over 3. And then we have 5 pi over 3 down here. All right, so now we got to get some coordinates. Now notice this is the exact same triangle. So for example, if you struggle, I always like to draw it in. So I draw in the triangle there, and I go, hey, this triangle here is the same as the green one we had down here just a second ago. So guess what? It has the same coordinates, but they're flipped because now the shorter side is the x, so we're going to use 1/2 first. So that's 1/2 comma root 3 over 2. And the reason it's root 3 over 2 is because this vertical side is the longer side. Over here, again, it's just a reflection. So negative 1/2 and root 3 over 2. And then down here, we have, excuse me, negative 1/2 and negative root 3 over 2. And then over here, we've got 1/2 and negative root 3 over 2. So what I would suggest to you is that as you study, what you might do is try to generate this thing from scratch. If you can't generate this whole circle perfectly by yourself, you're not ready for a test on it yet, okay? You should study to the point where this becomes very comfortable for you to generate any value on this circle. And you're allowed to draw it. You can use drawing as your aid, but this is something that you need to be able to do to answer questions. All right, simplify, verify, solve. This is actually the reason why I'm making the video, because many of you told me this was your biggest concern, and so I want you to have sort of a guide or a reference to go back to be reminded of how these work, because maybe we didn't have as much success previously with this as we wanted to. So I'm not going to spend a bunch of time specifically or explicitly on simplifying, and the reason for that is because we're going to use simplifying skills when we do the verifying and solving problems. I've got a handful of questions for each verifying and for solving that we're going to go through today. So before we do that, I want to remind you of the basic strategies we're going to use. Okay, so one of the things we can do, we can rewrite the information with sines and cosines only. So like we may try that in the first one. We have tan here. We may write that as sine over cosine. We can use Pythagorean identities, which I'll remind you about in a second. If you see fractions that are added or subtracted, we might need a common denominator, and we've got that going on right here. And then finally, guys, be creative. Try something, okay? It's going to be some sort of an algebraic thing that you got to do. I also want to remind you, when we're verifying, that's when we have an equation. We have to work on the two sides of the equation independently. We cannot do things like adding tan to both sides or dividing by 6 on both sides. Okay, so let's just take a quick diversion, make sure we remember what the Pythagorean identities are, because I'm going to be using those in these next questions that we go over. Okay, what we remember about the Pythagorean identities is that on the unit circle, if we're on the unit circle, our x is left and right, and our y is up and down, and the radius is always 1. And since, just like we saw in the unit circle a minute ago, we can always make a right triangle, that satisfies the Pythagorean theorem. X squared plus y squared equals 1 squared in this case. And so what we're going to remember is that in trig, x is the same thing as cosine. So that's cosine squared, and we'll call it theta in this case. So we know it's the angle. Cosine squared theta, y is sine, so sine squared theta equals 1. That is the first Pythagorean identity. We need to remember that we're able to modify this thing to meet our needs because not everything is cosine and sine. Sometimes we have secant, cosecant, tangent, and cotangent. So what we do is we divide it by either cosine or sine. If we divide by cosine, that becomes a 1 plus tan squared. And if we divide it by cosine, 1 over cosine is secant. If we had divided by sine, we would have had cotangent squared plus 1 equals cosecant. Now, I do want to point one thing out. I forgot to mention this in the beginning of the video. I wanted to remind you that any function and its cofunction, in terms of trig functions, like sine goes with cosecant, cosine goes with secant, and tan goes with cotangent. Remember, we're only saying co one time. So for example, a lot of people mess this up. They say, oh, cosine, cosecant, they go together. But listen carefully to my syllables. Cosine, cosecant. I've said co twice when I do that, which means that's not a pair. So sine, cosecant. I said co once. That's a pair. Cosine, secant. I said co one time. That's a pair. Tan, cotangent. No one messes that one up. That's an easy one. Okay, let's get back down to our Pythagorean stuff. And the reason I bring that up is because this works just a little bit differently. Because with these, you see how now we have, in our first one, we have cosine and sine go together. Okay, we said co once. Tan, secant. We didn't say co at all. Cotangent, cosecant. Didn't say that at all. I forgot to square this, it looks like. Okay, and guys, that's okay. That's what these identities are. So notice that's a difference you have here. Now this one will be given on a formula sheet. These two will not be given on the formula sheet. You'll need to either memorize them or remember how to derive them by dividing by sine or cosine. Now that we have those, let's go answer some questions. Okay, let's verify this first one. Okay, so here's what I'm going to do. I could get a common denominator, or I could use sines and cosines, and I may end up doing both. I'm not going to start with a common denominator. And the reason my choice is not that it's wrong. I don't want to do that because I don't see yet how tangent is going to relate to sine and cosines. I'm looking at that side. But what I am figuring out, though, I could rewrite this as 1 over tan, which would be 1 over sine over cosine. And I could write tangent as sine over cosine. Always put in your equal sign. I don't have any steps I want to do on this one, so I'm not going to write it right now. Over here, I am going to flip and multiply. So I get cosine x over sine x, plus sine x over cosine x. Okay, I'm starting to see that there's some potential here because I'm hoping to get sine and cosine in the denominator. And notice on the left, there's addition, but I do have sine and cosine in the denominator. I have fractions that are added together, so I'm going to go ahead and look for that common denominator now. And so over here, I'm going to multiply by sine over sine. And over here, I'm going to multiply by cosine over cosine. And so now, let's see what I have. I have cosine times cosine. That's cosine squared. And I have sine and sine. That's sine squared. And then the denominator is common, so I'm going to write it one time. That's cosine times sine. And look at that. Cosine squared plus sine squared, we remember from the Pythagorean identities, is 1. And so now I can make that substitution. So I think I will. So that would say 1 over cosine x times sine x equals, and hey, what do you know? That matches exactly what I was trying to do. So I don't need to waste my ink writing this every single time. I'll just draw an arrow straight down. That says, hey, I didn't change anything. I'm just copying, doing a copy-paste thing here. Okay, so 1 over sine x cosine x. So remember, the set of rules for verifying is you work on one side at a time, and you work on them until the two sides look the same. Here I have the two sides look the same. I get the cosine and sine are out of order, but we remember with multiplication, the order doesn't matter. So we're all good. This one's done. Let's try another one. Okay, if you're feeling brave, start it on your own. See what you got. Or at the very least, pause the video, write it down, and see if you can come up with a strategy that might work. See if I use the same strategy. In this one, I can only see one way to approach this problem that's going to be fruitful. On the left, I see there's two terms. Sine x is one term, sine x cosine squared x is another, and I notice they both have a sign in common. That's a hint to me that I can factor out the sine x. So I'm going to factor out sine x, and when I do that, I get 1 minus cosine squared x, and that equals sine cubed x. Now, right here, I'm looking at a Pythagorean identity. I'm going to take a minute. I'm going to remind you of why that's a Pythagorean identity and how we would know that. And what we did when we learned this, we do a little bit of side work. So we start with the main one, cosine squared plus sine squared equals 1, and we modify this to make it fit what we have here. Here I have 1 minus cosine squared, so I'm going to do a minus cosine squared. Better do it on both sides. So those cancel, and so what I have here now is sine squared is the same as 1 minus cosine squared. If 1 minus cosine squared is the same as sine squared, I'm going to sub that in. And look at that. I have sine times sine squared, so that's like sine to the first times sine squared. That's sine cubed. So this question is done. All right, let's try a couple more. And again, you're encouraged to pause the video and start it on your own first and see if you can figure out what to do. This one, you've got to be quite creative. I find this one to be pretty tricky, and that's why I'm including it in the video, because there's not a lot to bite on here. This is where I said one of the strategies is you just have to be really creative. This is one of those, because if I only can operate on one side at a time, I can't get a common denominator because there's not multiple fractions. And I can't express things in sine and cosine because that's already done. I can't factor things. So here's what I have to do. I'm going to multiply by the conjugate, which is not something that we often do. It's not super common this year, but it is something you can do. So I'm going to multiply by 1 plus sine of x, 1 plus sine of x, and I'm going to see if I can make this thing workable. Let's try it. So I get 1 times 1 is 1, and I get 1 times negative sine is minus sine, and here's a plus sign, so they cancel. And then I multiply those, and I get minus sine squared x. And then in my denominator, I get 1 plus sine x cosine x. And that may not look like it's done anything, but it actually has. Here's why. 1 minus sine squared x, as we saw a moment ago, that's the same as cosine squared. So I can rewrite this as cosine squared x over 1 plus sine x cosine x. And what that allows me to do then, I've got a cosine squared on top and a cosine on bottom. So I can cancel one of these with one of these, and all of a sudden this question just became complete, because if you look, that left side now matches the right side all of a sudden. So let's write in our answer. So I get cosine x over 1 plus sine x equals cosine x over 1 plus sine x. Now, how would you recognize to use that conjugate method? This is the thing that always frustrated me when I took precalculus personally, is my teacher would make it look really easy. Oh, it's going to be a conjugate method, and we're just going to multiply by the conjugate here. Honestly, guys, my best answer to that is you just have to practice a bunch and gain the skills so you recognize it. It's all pattern recognition. And it's not that I knew for sure it would work. It's just that I didn't have a whole lot of ideas, so I tried something, and it turns out that it worked. That's usually what the experience of solving these and doing real mathematics is like. Okay, so and anytime I had a 1 minus something, I could put down a 1 plus something and see what happens. Okay, let's try one more. And again, you're probably ready to get this going on your own, so if you're feeling it, go for it. All right, here we go. The obvious strategy to start on this one is to get everything in terms of sine and cosine, so that's what I'm going to do. So cosecant we know is 1 over sine, and we're using beta in this question, and then that's over sine beta. Minus cotangent is cosine over sine, and tangent is sine over cosine, and that's going to equal 1. All right, so now what? Let's see. I could put this over 1, and now it looks like I could flip and multiply on both of those fractions. I think I'll give that a shot. So we'll multiply that up, and we'll multiply that up, and I'm going to get 1 over sine squared beta minus, and then when I flip this, the cosine goes on top, so I get cosine squared beta over sine squared beta equals 1. Need a little more space, so I'm going to scroll down and zoom out a little bit. And look at that. I have 1 minus cosine squared, which we saw recently, and guys, look, it's popping up. All these Pythagorean identities are all over the place. So now what I'm looking at is I have 1 minus cosine squared, so that's sine squared over sine squared. Hey, that's clearly 1. So I'm going to go one step further, and I'm going to write out that it actually is 1. 1 equals 1. Okay, so that's sort of our examples on verify. If you want more examples, which I would understand, obviously, there are more examples back in the section in chapter 5 when we learn this, or unit 5. Now let's switch gears for a minute and talk about solving. Okay, and we're going to do 3 examples and look at some of the different things that happen when we're solving. The difference for solving is we're actually going to find theta. We're going to have some numerical answer typically when we do these. So I want to remind you of some of the basic skills that you'll need. And this is one of the reasons we started with unit circle review today. All right, first thing you need to do, you're thinking about, I'm getting theta by itself. Now it's so interesting because guys, if I wrote a question like 4x minus 1 equals 0, I suspect every one of you would say, oh, add 1 and divide by 4 and x is 1/4. I think you'd find that really intuitive. But for some reason, when we put a cosine squared in here, people don't see it. Remember, this is the variable. This is what you're trying to get by itself. So we can still do things like add 1 and divide by 4. Exactly what I did here. So we get cosine squared theta equals 1/4. And if something were squared and you didn't want it squared, I think you know you'd square root it. Sometimes we don't recognize it for some reason here, though. So now we get cosine squared. Oops, except it's not squared, sorry. It's not squared anymore. So we get cosine theta equals plus or minus, be careful when you take a square root of plus or minus 1/2. Square root of 1/4 is 1/2. So now we're looking at the unit circle and we're asking where on the unit circle do we have an x value, because cosine's x, do we have an x value that is either 1/2 or negative 1/2? 1, 2, 3, 4. And now we get to name those locations. This one, so we have pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So those are our 4 locations. Okay, and that's the steps to do it. That one is a pretty simple one. The next one may get a little more exciting. Let's see. Tangent, everyone's favorite. Let's give it a shot. Okay, it's the same thing. Okay, we're going to start out by subtracting 3. So we get tan squared x equals negative 3. I go to take a square root of that. And we have the square root of a negative number. So that doesn't seem to work. Let's modify the question and see if we can solve it, because perhaps maybe I've made a typo here. So let's make this a minus and see if that changes our outcome. Or let's see how it changes the outcome. Okay, so now if I do that, then I would be adding 3 to the other side, so I'd have 3. So then I get tangent of x equals plus or minus the square root of 3. And so this is the one where we have to think about remembering that tangent is y over x. There's some spot or some variety of spots on the unit circle where the y value divided by the x value gives us root 3. So we have to think about how could the coordinates of the unit circle been put together and simplified to be root 3. Guys, if it's a root 3, it's going to be root 3, oops, that should have been a 3 though, root 3 over 2 over 1/2. Okay, because if you multiplied the 1/2 up, the 2's would cancel and you'd be done. So what does that tell us? Our y value is something like root 3 over 2, and our x value is something like 1/2. So where does that happen? Well, hey, that's interesting. That's the same locations as the last question. So because we have plus minus, we incorporate all of these. So actually, our answer is the same as last time. So pi over 3, and 2 pi over 3, and 4 pi over 3, and 5 pi over 3. Let's do another one. One that takes a little bit more creativity. And this is one that, with a little bit of study, you can be very successful at. We did well. Those of you who studied hard did really well when we did this one, but it probably is not as fresh as it needs to be right now. Okay, so this one's a little different because we have sine both squared and in a linear term. So what we want to do is recognize, hey, this looks like a quadratic equation. We can rewrite it like this. Sine squared x minus sine x, minus 2, I'm moving the 2 to the other side, equals 0. And the reason that's important, that 0 is important, because now it makes it factorable. Now what I encourage you to do, this is the thing that really helped me when I struggled with these when I was taking precalculus, is rewrite an easier question, solve the easier question, and then apply that understanding to this one. Here's what I mean. Write a question like this one. X squared minus x minus 2 equals 0. Look at the similarities between this and our question. Let's try to factor this one and see what happens. Is this factorable? Let's see. We've got a 2 and a 1. We need them to multiply together to be negative 2 and add to be negative 1. So if I do minus 2 plus 1, I think that works. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. That's how it factors. So guess how this one factors? So we get sine x minus 2 times sine x plus 1, exact same factoring. Now we get to answer the questions. Let's solve this thing. So this would say sine x equals 2, and this one would say sine x equals -1. And now we get to ask ourselves, where on the unit circle do those things happen? Where we achieve a sine value, which is a y value. Where do we achieve a y value of 2? Well, never. The unit circle tops out at 1, so that one never happens. However, this one does happen. Sine achieves a value of -1 right down here. So the answer to this one is 3 pi over 2 because that's that location. All right, what have we not covered in this video? And what are we not going to cover? The thing that I've not covered yet that really jumps out at me that will for sure be on your test is the laws of sines and cosines. Okay, that's absolutely going to happen. Now, we had lots of good examples when we did this one, and guys, you did really well on this. And we had this test. This was the section of the test that you absolutely nailed. So I want to refer you back to that in the old homeworks and the old reviews and the old videos, because I think you're going to do really, really well on this with just, I mean, honestly, just a little bit of study and practice. You're going to do great on this one. That's going to be all for today's video. We'll do more stuff in class. Hope this was helpful, and we'll see you next time.